Control of combination superheaters. Steam temperature control by combination of superheater. Superheat oblique reheat steam temperature control part 3. In this schematic diagram of a boiler, we can see that the saturated steam is coming from the top of the boiler drum. Then it is passing through the radiant superheater. After that, the steam is going to the convective superheater. So, radiant superheater and convective superheater are forming a combination. In this lecture, we are going to talk about control of this combination superheater. If we measure the steam temperature in convective superheater, we shall find that with the steam flow, that is the increase in load, the steam temperature of convective superheater increases. And if we measure the temperature of steam in the radiant superheater, we shall find that with increase in load, the steam temperature in radiant superheater decreases. So both the curves are compensating in each other. That means they are cancelling each out. And when we see the combination of the two, we find that it is little bit flat curve. That means the steam temperature of convective superheater has compensated the steam temperature of radiant superheater. How it is happening, the reason for this is being explained in the next few slides. Request. It is hoped that this session is going to be useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा. The control of a combination radiant convective superheater is relatively simple because of its compensating characteristics. Why we call it compensating? See, one curve is rising, other curve is falling, and if we combine both, then they are compensating each other, and the ultimate curve is little bit flat. That's why we call these two characteristics as compensating characteristics. With an increase in steam demand, both fuel and air flow increase, because if the steam demand increases, you have to increase the fuel, and correspondingly you have to increase the airflow also to burn that fuel, resulting in an increase in flue gas flow. Of course, when the fuel is burning and in the presence of air, of course, if both are increasing, then the flue gas is also increasing. As a result, convective heat transfer coefficients increase. So this is obvious. When the flue gas flow has increased, then the heat transfer to the convective superheater will increase. Thus, steam receives greater heat transfer per unit mass flow rate, and then steam temperature increases. We are talking about the convective superheater. The radiation heat transfer is proportional to the flame temperature, which is not strongly dependent on load. Flame temperature shall remain the same. Thus, an increase in steam flow due to an increased load demand would result in a reduction in exit steam temperature. We are talking about the radiant superheater. So, because of increase in steam flow rate, exit steam temperature of the radiant superheater shall decrease, which is the opposite effect of a convection superheater. Request: it is hoped that this session was useful to you. Please press like button. Please subscribe this channel. बहुत शीघ्र यह लेक्चर आपको हिंदी में भी उपलब्ध होगा.